Hi everybody. Just a short lecture this week in terms of I just want to explain to you um, a couple of things in relation to the Python programming and talk to you a little bit about using while loops and kind of for loops, and just to explain them in terms of how they can be used in terms of changing variables and their values, and then talk a little bit about user defined functions. So you might have seen this example here. Very straightforward. Import time a is equal to 0, so just setting up my variable there. And there's this statement called while true and then followed by a colon. So effectively what's happening here is you're incrementing a each time by 1. Okay, and you're just pausing it after a second. That's what the time.sleep is. So I'm just going to open that up on the create a new one there on mu. So I'm going to say to myself import time, so I set it up first, and I'm going to get a variable a, and I'm going to set a value for 0. Okay, I'm going to use my while loop, so while true. I'm going to say a is equal to a plus 1. What that effectively is doing is I'm taking a value for a, which I've already set at the start, which is 0, and I'm incrementing it by 1 each time, and I'm going to get it to print a. So I'm going to deliberately leave out the time.sleep for a second, and if I click run on that, and I'm just going to save this. Notice at the bottom here the numbers are just shooting up really fast and it's counting really quickly. I don't want that because it's very hard to follow, right? So I'm adding another element to control with this, right? So what I'm going to do is I'm just going to add another line here and code time. So I'm calling on my library that I imported, which is time, so time.sleep. And I'm going to say 1 second. So you can even see there on the little pop-up window it says sleep, and it has brackets, and then it has seconds in it. So I'm just going to say 1 second. So effectively what I'm going to do is going to get it to print a, but I'm going to get it to do it at 1 second intervals. And the beauty of that then is it's just showing me it's counting and iterating through the numbers, incrementing the value of a by 1 each time. And that's very useful, right? Now, that will keep going and going, and if I left it running all night, it will keep going. So there's a couple of things then with a while true loop, right? I can kind of control that in relation to, I could do it a couple of ways. I could throw in an if statement there. So I'd say if a is, let's say, less than 5 for argument's sake, right? And I use my colon, and then I indent, just make sure I indent that to the if statement then, and I run that. You should see there it'll start to print 1, 2, 3, 4, 5, and then it stops. Okay, why does it stop? Because I have told it if a is less than 5 to keep incrementing a, but once a gets above 5 it's going to stop the program effectively. Now I could use if statements to control it. Also what I could do is I could actually play around with the while at the top of the instead of true. So I could say while let's say a is less than 7. Sorry, didn't hit the shift key. So while a is less than 7, it's going to count here, right? And you can see there it's counting up 4, 5, 6, and 7. And now the program stops. Okay, so I've actually used the while loop, and I've made it finite in terms of I've set a limit to it. So that's just a contrast. While it's true, the while true loop is effectively using Boolean logic, which basically means true is always going to be true, so it's always going to keep running over and over again. So that's very useful then if I want to set limits to certain iterations and counting through certain things. And all of this stuff that we're doing here is to help you with the arithmetic and the kind of analysis of the data that you're using for your that you're gathering for your environmental project. And this might be useful in certain cases. To contrast the while true loop, I'm going to just use a for loop, right? So I'm just going to import my time again because that's useful. And then also I'm going to, in this case, I'm going to use for. So for, so pick a variable, so I'm just going to call it, make a variable, call it x, in range. So I'm going to give this a range, and I'm going to say 1 to, let's say 6, right? And I'm going to use my colon, and what I'm literally going to get it to do is I'm going to get it to print x, right? And I'm also going to use my time dot sleep, and I'm going to basically run that. So, and you'll notice there again, it's just going to run through and iterate through those numbers, right? And then it stops when it comes to 5. Why does it stop at 5? It basically sets the limit at 6, so it always decrements or comes back 1 from that value. So for example, if I wanted it to count to 10, I'd actually put in 11 there. So if I ran that again, you will see this will count through and it'll go right up until it reaches 10, and then it should stop. So the for loop is just a variation or a difference where I can actually set a range of values for and get the program to iterate through that for in this case the variable x. So that's very useful to know in terms of for loops as well, and those kind of examples there. So we're literally taking a variable and we're adding and incrementing it to it kind of each time. So the just on the while true loop, and if I go back to an example from last week's tutorial, and that was where you had to find I think it was activity 3 in the second section, where you had to input a letter and detect whether it was a vowel or not, right? So I'm just going to use a while true loop for that one. So I'm going to say while true, and I'm going to create an input, and I'm going to call that input letter, right? And I'm going to equal it to input, which is my input function, which the computer effectively allows me to input or type into it. So I'm going to say input letter, and I'm going to close those brackets, right? And then what I'm going to get it to do is say if, I'm going to open brackets, letter, which is my variable, letter is equal to, or in this case the 2 equals to is kind of, I'm not assigning it a value, I'm just comparing it. So you see there in letter equal to input, brackets input letter, there I'm assigning a value to letter. In this case I'm only comparing it, so that's the reason for the 2 equal to signs as opposed to just 1 equal to sign. So I'm going to say so if I just use my vowels, right, and say A, E, I, O, U, so I'm going to say A, or it could also be a capital because the question asks is it a capital either. So letter compares to capital A, and so on. So A, E, I, O, U. So I kind of already have it done out here. So I'm going to get it to, I'm going to just save me typing out all that, all the different vowels. So effectively what I have in the inside the bracket, so if letter is equal to A or to letter capital A or to E, I, O, U, I'm basically checking if it's a variable, right? Or if the variable is equal to any one of those. And essentially if it is, then I'm just going to get it to print a statement to say letter, which is my variable, and then I'm going to add a bit of text to that then. So letter is a vowel, and I'm going to close brackets there, okay? And if it's not, so I'm going to use my else. I could just say something like this is not a vowel, or so I'll just get it to print this is not a vowel. So just zoom out on that one a bit there. So again, I'm using my while true loop. That is important in terms of reiterating this. Just reiterating this and allowing me to repeat it. So it says, it's asked me the question here, input letter. So I'm just going to put in E, press enter, and it says E is a vowel, which it is, of course. So it's checking it there in terms of, and I know you were trying to do this last week, and I hadn't kind of given you enough of a context for this. So A is a vowel. If I put in capital A, it also says A is a vowel. If I put in the letter C, and it says this is not a vowel, and so on. So you can see, but the advantage of this, or if I'm repeating a lot of things or I need to check things over and over again, the while true loop allows me to reiterate that over and over again. So that's very useful in terms of checking for the letter, or if a certain value is used. So the other thing I want to talk to you about is user-defined functions, right? And one of the examples is the you would have seen it last week in the tutorial as well, and that's Pythagoras' theorem, right? So we know that Pythagoras' theorem is the hypotenuse squared is equal to the opposite and the adjacent, or the opposite squared plus the adjacent squared. And in the function we have set up here, right? So a user-defined function is identified by the DEF, and then we give it a name. So in this case, Pythagoras, and we can give it inputs, or in this case, we've A and B. So side A and B. So A squared plus B squared is equal to C squared. We also import the library mat, because in mat we have what's known as square root, so SQRT, right? And the square root SQRT, so of A squared plus B squared, so A by A and B by B, that returns C, okay? And that's very useful then for actually trying to, if we had to repeat, or had a lot of wanted to use the same function over and over again. So if I just run this example, you can see there, I can give it values, or I can input values there for side A, so I call side A 3, side B 4, and I get the calculated hypotenuse of 5. How that's working is the hypotenuse, or the value for the hypotenuse, is Pythagoras and the two inputs in terms of the sides, so side A and side B. And I've set the value for side A and side B as 3 and 4, and you can see Pythagoras is the function up there. So literally what I do when I say print, when it says here print hypotenuse, this variable here, it's essentially calling on Pythagoras, which is the function I've defined up here, and inputs for side A and side B. So that's really useful then if I wanted to repeat that kind of function over and over again. To explain it in simpler terms, right? Let's say I wanted to, I'm going to define a function here. I'm going to use a very basic one. I'm going to say, call it addition, right? And I'm going to have two inputs into it, and I'm going to say x and y, okay? So I want this function to perform something. So I'm going to get it to do a simple addition. So I'm going to get, say, z is equal to x plus y. And what I'm going to do is I'm going to get it to print z, okay? And essentially, if I want to call on that function, so I have my function complete here. So DEF, that's denotes it's a user-defined function. I've given it a name. In this case, it's called addition, and I have x and I have y as two possible inputs, okay? So I assign the values for x and y, and then what the function does is it calculates x plus y is equal to z, and it prints z. So I'm going to call on that function, and I do that by saying addition, and I'm going to give 4, comma 5. So I'll give a value for x and y, and then I'm going to call on it again, and I'm going to say 9 and 8. And then I'm going to call on it again, and I'm going to say 2 and 6, 2 comma 6. Okay, so they're my values for that, right? So if I run that, it so addition is not defined. I haven't spelled it correctly there in my definition or in my call of it. So if I just correct that, run that again, and go addition. So what this does is it looks addition 4 and 5. It looks for a function called addition, which is up here. 4 and 5, so there's values for x and y. So z is equal to x plus y, which is 4 and 5, and it prints z. So you see down here then what I end up doing is I have the addition of x and y, and then for the second one it's 9 and 8, which is 17, and for the third one it's 2 and 6, which is 8. So if I call that on that one again, and I said put in, and let's see, put in two large numbers, and I called on that, you can see there it adds up those numbers for me in relation to no matter what the values are. So that's really useful then if I want to repeat a function over and over again or call up on it a number of times. So this will be useful in terms of kind of trying to make your way through the data and compute the data that you gather from your kind of environmental project. Okay, so take a look at those examples of user-defined functions that I left in the tutorials last week, and if you have any questions, please just ask. Okay, just to kind of wrap up then, essentially identifying the variables. If you're trying to break it down in the code, think about the variables that are in it. How many are there? Where are they kind of situated in the program? Is there conditional statements involved? Can you write down what the program intends to do? And just try and think logically through the program and the problem you're trying to solve. Even breaking it down into simple English and imagining what you'd like the function or the program to do, and that might help you write the code then and break it down. So that have a go and see how you get on, and don't hesitate to ask me if you have any questions. Thank you.